Alright, I think I'm finally getting the hang of this a little bit. Let's try another lesson. This will be section 10-3. All students will be able to apply theorems about the chords of a circle. So let's take a look at this circle right here. And let's call this, as usual, circle O. In circle O, I'm going to draw segment RS. You know that we call that a chord, so there's going to be chord RS. This chord cuts off two arcs. It cuts off minor arc RS and major arc RTS. When we talk about chord RS, that minor arc, we say that is the arc of chord RS. So minor arc RS is the arc of chord RS. That's the arc and the chord. So we can write a theorem. This will be theorem 4.2. That is homework theorem 9-4. And it states, in a circle or in congruent circles, two minor arcs are congruent if and only if their corresponding chords are congruent. In a circle or in congruent circles, two minor arcs are congruent if and only if their corresponding chords are congruent. So for example, let's say that we had arc RS, and over here we have arc TU. What we're saying is, if segment RS is congruent to segment TU, then arc RS is congruent to arc TU. And since it's an if and only if statement, the converse is true as well. That is, if arc RS is congruent to arc TU, then segment RS is congruent to segment TU. Let's briefly outline the proof of this. So let's say that we draw these radii, 2 points RS, T, and U, and we know that all radii of a circle are congruent. So all of these pieces are going to be congruent here. And we're also saying that segment RS is congruent to segment TU. So do you agree that that means that the measure of angle ROS is congruent to the measure of angle TOU? Since the measures of their central angles are congruent, that means the measure of those arcs are going to be congruent. That is, the measure of arc RS is congruent to the measure of arc TU. And that's kind of an outline of the proof. And you could do something similar if we're talking about the circles being congruent, because if the circles are going to be congruent, that means that the radii are also going to be congruent. And you might imagine how that proof is going to proceed. Alright. Here is a circle. And let's be imaginative and call this circle O. And let's draw this arc X, Y, and Z. Just because I'm labeling with 3 letters doesn't mean it has to be a major arc. You'll see in a minute why I'm calling this arc X, Y, Z. And what we're going to say is that point Y is the midpoint. I'm trying to get a handle on the handwriting with this app. It's not quite what I thought it was going to be. Point Y is the midpoint of arc X, Y, Z if arc X, Y is congruent to arc Y, Z. Which makes sense. That follows from our definition of the midpoint of a segment. If the point's the midpoint of a segment, then the 2 segments formed are going to be congruent. So if point Y is the midpoint of arc X, Y, Z, that means the 2 arcs, X, Y, and Y, Z, are going to be congruent. And we can talk about any lines, segments, or rays that contain point Y. We can talk about them bisecting angle X, Y, Z. For example, if I drew a line through point Y, we would say that that line bisects arc X, Y, Z. Now, let's see if this undoes it. Why? Oh, I can't undo that blue line now. But that's all right. Moving on. All right. That leads us to theorem 10.3, which is homework theorem 9-5, which states that a diameter that is perpendicular to a chord bisects the chord and its arc. A diameter that is perpendicular to a chord bisects the chord and its arc. Let's do a quick proof of that. So here's our circle, and here's the diameter, or a diameter, of that circle. And what we're going to do is we're going to draw a chord that is perpendicular to that diameter. Let's call these points X and Y, and let's call these points A and B. So we're saying that if AB is perpendicular to XY, then that diameter bisects the chord. So if let's call this point Z, that means that Z is the midpoint of segment XY, and point B is the midpoint of arc XY. And to be specific, we'll call it XBY, so you can specifically see which arc it is we're talking about. And again, it's probably not that surprising to see that this is going to be true. If I draw radius OX and radius OY, can you see that we form 2 right triangles, OZX and OZY? Well, since these radii are congruent to each other, and segment OZ is congruent to itself, we can see that segment XZ is going to be congruent to segment YZ by CP. Well, the 2 triangles are going to be congruent by HL, right? And now we can say that segment XZ is congruent to segment YZ by CPCTC. Also, angle OYB is going to be congruent to angle XOB. And I have a pointer here I can use. Angle YOB is going to be congruent to angle XOB. Since those 2 central angles are congruent, their arcs are going to be congruent. arc YB is going to be congruent to arc XB. So you can see why those are going to be the midpoints. So look at an example. Let's call this example 1. Find the length of a chord that is a distance of 5 units from the center of a circle with radius 8 units. Find the length of a chord that is a distance of 5 units from the center of a circle with radius 8 units. So let's draw a picture of what we have. Here's our circle, and we have a chord that is 5 units from the center of the circle. So this distance here is 5. We also know that the radius of our circle is 8 units, and we want to find the length of that chord. Well, if we're talking about the distance from a point to a line, that means we're talking about a perpendicular distance, which means this angle here must be a right angle. That is, it represents that 5, remember, is the distance from the center to that chord. The distance from the point to a line is that perpendicular distance. So what we could do is we can use the Pythagorean theorem to find, let's call this x, the value of x, and since we know that this point right here is going to be the midpoint of that segment, if I double x, that'll give me the length of that entire chord. Therefore, we're going to say that 5 squared plus x squared is equal to 8 squared. So x squared is going to be 64 minus 25, or 39. X squared is going to be 39. So x is going to be the positive square root of 39. So the length of the chord is going to be 2 times the square root of 39. Make sense? Alright. Now, it doesn't matter where I orient the circle and this chord. If I'd move that chord to any other place on the circle, do you agree that if it's 5 units away from the center, the length of that chord will always be 2 times the square root of 39 units long? Well, since it doesn't matter, we can kind of conclude, well, never mind kind of, we can conclude the following theorem. And this will be the last theorem lesson. This is theorem 10.4, which is homework theorem 9-6. In a circle, or in congruent circles, two chords are congruent if and only if they are equidistant from the center of the circle. For example, I guess, is this example 2? I don't know, I lost track. Let's say we have this circle, and I'm going to call it circle Q. Yep, keeping you on your toes. And this is going to be chord RT, and this is going to be chord OV. The distance from Q to chord RT we'll call it x, and the distance from point R to that center, to the intersection there, that is going to be a distance of 3 units. The distance from Q to OV is going to be 4 units, and this time all of OV is going to be equal to 6 units. So, since we know that 3 is the distance from R to the midpoint of RT, we can conclude that the measure of RT is also equal to 6 units. Well, since segment RT is 6 units and segment OV is 6 units, that is, both chords are congruent, we can conclude that they are equidistant from the center of the circle. Therefore, we can conclude that x must also be equal to 4 units. And again, that should give you enough information to work on your classwork tomorrow. If you have any questions, work with the people around you, drop me an email if you need to. If you ever drop me an email, make sure that you include a copy of the problem so I know what it is that I'm looking at. I also suggest that if you might want to bring your book to class so that if you have to look anything up, that you have the opportunity to do so. Okay? Have fun. I'll talk to you guys later.